Welcome to Lucid Mind Chemistry channel. In this video, I have put together some questions related to the topic Tri-iodoform test. For links to other topics and question timestamps, please visit video description.
Question number 38. Which compounds will produce a yellow precipitate with alkaline aqueous iodine? Now this is a factual question. You must remember that alkaline aqueous iodine gives yellow precipitate with three types of compounds. So it gives positive result with number 1, if you have methyl ketone, that is CH3 C double bond O R. So on one side of the ketone there must be a methyl group present. Second is ethanal, CH3 C double bond O H. So this one gives positive result with aqueous iodine. Third one is with the secondary alcohol group. So we have CH3 COH and R. If these three types of compounds are present, then always a yellow precipitate is formed. So let's see which one of these is present in the given compounds. Number 1, this is carbon atom. So this OH is tertiary because this carbon atom is further combined with 1, 2, 3 other carbon atoms. So tertiary does not give positive result. On the other side we have aldehyde, which does not have any methyl group. So this is unable to give the precipitate. Let's see the second one. We have OH group attached to this carbon atom, and this carbon atom is further attached to two other carbon atoms, so it is secondary alcohol. Yeah, it can give positive result. Now going to the third one, we have secondary alcohol. Yeah, this one gives positive, and this one is tertiary alcohol. It does not give positive result. So it means compound 2 and compound 3 will give yellow precipitate with aqueous alkaline iodine. So the answer is C. Question 25. An alcohol has the molecular formula C5H12O. It has several isomers. Which isomer forms a yellow precipitate with alkaline aqueous iodine? So we know that the only alcohol that can form precipitate with aqueous iodine is CH3COH. This type of alcohol can always give positive result with aqueous iodine. Now let's see among these four which one has this type of alcohol compound present. The structure of 2,2-dimethyl-propane 1-ol will be like this. We have propane. On first carbon we have alcohol group. On second carbon we have methyl and again methyl group. So this is 2,2-dimethyl-propane 1-ol. Now you can see there is no methyl group attached with this carbon atom as was in this case. So this cannot give a yellow precipitate. B is 2-methyl-butane 2-ol. So let's draw the structure first. As you can see, with the alcoholic carbon atom we have 3 carbon atoms directly attached. So this is tertiary alcohol, and tertiary alcohol does not give positive result with aqueous iodine. Only secondary alcohol can give positive result with aqueous iodine. So this is wrong. Now drawing part 3. We have 3-methyl-butane 2-ol. On second carbon we have alcohol, and on third carbon we have methyl group. Now in this compound you can see that the carbon atom directly attached with the OH group has one methyl group attached, and it is secondary alcohol, so it will give positive result with aqueous iodine. Last one is pentane 3-ol. We have 5 carbon atoms, and on third carbon atom we have alcohol group. As you can see, there is no methyl group directly attached with this carbon atom, so therefore this does not give positive result. So the only option is part C. Question 39. Which alcohols can be oxidized to form an organic compound which will give colored precipitates with both 2,4-DNPH and alkaline aqueous iodine? Now you should remember that 2,4-DNPH gives colored compound with aldehydes and ketones. While alkaline aqueous iodine gives colored product only with product having methyl group directly attached with carbonyl carbon. This must be present. Looking at the first one, we have this carbon atom which is directly attached to 2 other carbon atoms, so this is secondary alcohol, and secondary alcohol is oxidized to ketone, so it will give this product. This is a ketone, and it will give colored product with 2,4-DNPH as it is a ketone. But with alkaline aqueous iodine there must be CH3 attached with the carbonyl carbon, as no CH3 is attached with the carbonyl carbon directly, so therefore this will not give colored product with alkaline aqueous iodine. In second part we have secondary alcohol, because this carbon is directly attached to 2 other carbon atom. We also have a ketone, as this carbon is attached to 2 alkyl groups. So upon oxidation, ketone is not affected. Secondary alcohol will convert into ketone. Now we have 2 ketone groups in the product. As we can see that the ketones are present, so therefore 2,4-DNPH will give positive result and colored precipitate is formed. And we can also see that CH3 is directly attached to the carbonyl carbon, so therefore alkaline aqueous iodine will also give colored precipitate. In part 3 we can see that this carbon is directly attached to 2 other carbon atoms, so therefore it is secondary alcohol and it is oxidized into ketone. The product will be like this. As the product formed is ketone, so therefore it will give colored precipitate with 2,4-DNPH. Also we can see that CH3 is directly attached with the carbonyl carbon. So due to the presence of this part, it will give colored compound with alkaline aqueous iodine. As option 2 and 3 are correct, answer is therefore C. Question 26. An alcohol with the molecular formula C5H12O decolorizes warm acidified potassium manganate 7. The alcohol also gives a yellow precipitate with alkaline aqueous iodine. What could be the identity of the alcohol? In the reaction they have given acidified potassium manganate, which is oxidizing agent. The second reaction is given with alkaline aqueous iodine and yellow precipitate is formed. Now we must know that for alcohol, in order to give positive result for this reaction, there must be a methyl group attached with the carbon having alcohol functional group.
If no CH3 is attached with the carbon atom having OH group, then yellow precipitate is not formed. Let's move towards the option. We have 2-methylbutane 2-ol. Let's draw the structure. A. We have 4 carbon atoms. On second carbon we have methyl functional group and also alcohol functional group. B is 3-methylbutane 2-ol. So again we have 4 carbon atoms. On second carbon we have alcohol functional group, and on third carbon we have methyl functional group attached. C is pentane 1-ol, so we have 5 carbon atoms, and the alcohol group is attached with the first carbon atom. In D we have pentane 3-ol, so we have 5 carbon atoms, and alcohol is attached with the third carbon. In A we have this carbon that is attached with OH functional group, and we can see that this carbon is attached directly with 3 other carbon atoms, so this is tertiary alcohol. And tertiary alcohol does not oxidize in the presence of acidified KMnO4. Let's move towards B. We have this carbon that is attached with OH functional group, and we also have a CH3 directly attached with this carbon. As the steric carbon is secondary alcohol, so it will oxidize to ketone functional group. We also have a CH3 directly attached, so therefore alkaline aqueous iodine will also give positive yellow precipitate of CHI3. So B could be the correct option. In C we have carbon atom attached with OH group, and this is primary alcohol, so the primary alcohol will oxidize itself to aldehyde. The second reaction is with alkaline aqueous iodine, as there is no CH3 directly attached with this carbon, therefore this won't give yellow precipitate. Similarly in D we can see that carbon atom attached with OH is secondary alcohol, so this will oxidize into ketone. But we can see that no CH3 group is directly attached with this carbon atom, so therefore it won't give yellow precipitate. The only alcohol giving both positive results is B. Question 26. Which alcohol will give a yellow precipitate when warmed with alkaline aqueous iodine? For alcohols, you should always remember that only that alcohol which is having CH3 group directly attached with the carbon atom having OH functional group will give positive result with alkaline aqueous iodine, and Tri-iodoform is formed, which is yellow precipitate. Let's move towards the options. We have A, 3 carbon atoms in the long chain. With second carbon atom we have 2 methyl groups attached, and with the last carbon we have OH functional group. Putting hydrogens. As we can see that OH is attached with this carbon, and there is no methyl group directly attached with this carbon, so A does not give positive iodoform test. B is alcohol having 2 carbon atoms in the long chain, and with second carbon atoms 3 methyl groups are present. Putting hydrogens. As we can see that OH group is attached to this carbon, which is directly attached to the methyl groups. But this is the example of tertiary alcohol, and tertiary alcohol does not oxidize. So therefore option B will not give positive result with alkaline aqueous iodine. In C we have 4 carbon atoms in the long chain, OH functional group with the second last, and also methyl group. Putting hydrogen atoms. Again we can see that OH is attached with this carbon, which is directly attached to 3 other carbon atoms. So this is also an example of tertiary alcohol, and tertiary alcohol does not oxidize further. So C is also incorrect. Moving towards D. We have 4 carbon atoms in the long chain and OH group is attached with the second carbon. Putting hydrogens. As we can see that OH is attached to this carbon, which is directly attached with one of the methyl groups, and it is secondary alcohol, so it will oxidize to ketone. And ketone having methyl group directly attached with the carbonyl carbon gives positive result with alkaline aqueous iodine. So D could be correct option. So therefore answer is D. Question 27. Structural isomerism only should be considered when answering this question. All the isomeric alcohols with the molecular formula C5H12O are added separately to form alkaline aqueous iodine. How many of the isomers give a yellow precipitate? Now alkaline aqueous iodine will give the positive results with only those alcohols that have methyl group directly attached to the carbon atom, which is attached with OH functional group. If there is no methyl with the carbon atom having OH group, then there will be no positive result. Let's draw possible structural isomers of C5H12O and let's see which one have methyl group attached with the carbon atom having OH functional group. As we have 5 carbon atoms, 1, 2, 3, 4, 5, OH could be attached with the first carbon, which is primary alcohol. So this has no methyl directly attached, so therefore this won't give positive result. There are other possibilities of this structure. We can draw them as this, where one of the substituent is on third carbon atom. Again, in the third possible structure we have OH attached with the first carbon, which is attached to the second carbon, and there are 3 substituents present on the second carbon atom. Again, this does not has any methyl group attached directly with this carbon, so therefore this won't give positive iodoform test. All these 3 structures were from primary alcohols. Now let's move towards secondary alcohols. In secondary alcohol, OH is attached to the carbon atom, which is further attached with at least 2 carbon atoms directly. Now in total we have 5 carbons, so it could be like this, or it could be like this, or another possibility is that there is a substituent attached with the third carbon. All these 3 are secondary alcohols. Let's see which one has methyl group directly attached to the carbon atom with OH. So this is the carbon atom with OH. It does not have any methyl group, so this won't give positive result. This is the carbon attached with OH and it does have a methyl group directly attached, so this will give positive iodoform test. Again, this carbon does have a methyl group, so this will also give a positive iodoform test. Now moving toward tertiary alcohol structures, we have OH, which is attached to the carbon atom, which is directly attached to 3 other carbon atoms, and as there are 5 carbons in total, so we can draw like this. This is the only possible structure for tertiary alcohol. In this structure we can see that the OH is bonded to this carbon, which is directly attached to 2 methyl group and 1 ethyl group, as we need just one methyl group directly attached to this carbon, so therefore this won't give positive iodoform test. So we only have two possible structures that give positive iodoform test. First one is pentane 2-ol and second one is 3-methyl butane 2-ol. So therefore correct option is 2. Question 38. Compound Y reacts with alkaline aqueous iodine to form a yellow precipitate. Changes the color of warm acidified potassium dichromate 6 solution. From first reaction we can infer that compound Y consists of CH3 double bond O or CH3 COH, because only these groups if present in a compound will give positive result with alkaline aqueous iodine. For second options we can infer that this compound can be further oxidized. Let's draw the structures. For first we can see that there are two carbon atoms and one OH group is attached. So this is primary alcohol, and primary alcohol can be oxidized to aldehyde. So second statement is true for this one. Also we can see that CH3COH is present, which is responsible for yellow precipitate of alkaline aqueous iodine reaction. So therefore option 1 is correct. Now in compound 2 we can see that we have two carbon atoms and also it is an aldehyde. This can be oxidized into carboxylic acid. And also we can see that this group is present, which is responsible for yellow precipitate formation. So 2 is also correct. For third compound we can see that there are three carbon atoms and it is a ketone, so we can write CH3 C double bond O CH3. Now ketone cannot be further oxidized, so therefore it won't change the color of acidified potassium dichromate, but it does consist of CH3 C double bond O, which is responsible for yellow precipitate in first chemical reaction. So only one result is positive. The answer is therefore B. Question number 27. Which reagent could be used to distinguish between ethanal and propanal? Now ethanal and propanal both are aldehydes. In ethanal we have two carbon atoms. In propanal we have three carbon atoms. Let's see how can they be distinguished from each other. A is 2,4-DNPH or 2,4-dinitrophenylhydrazine. It gives positive result whenever a carbonyl carbon is present. Now as carbonyl carbon is both present in aldehyde, both these aldehyde, so therefore both will give positive result with this product. So we cannot distinguish by 2,4-DNPH. We can draw the structure of ethanal like this: CH3 C double bond O H, and propanal will be like this: CH3 CH2 C double bond O H. Now B is iodoform test, presence of iodine and sodium hydroxide. Now iodoform test is always positive whenever there is CH3 C double bond O present. As we can see that in ethanal there is CH3 C double bond O present, but in propanal there are two carbon atoms with C double bond O. So ethanal will give a positive result with iodoform test,
and propanal will not give any test with iodoform. So therefore B could be used to distinguish between ethanal and propanal. C is potassium dichromate in the presence of sulfuric acid, as it is a strong oxidizing agent, so both ethanal and propanal will be oxidized to carboxylic acid groups. So both cannot be distinguished by this test. D is Tollens reagent. Both of these compounds are aldehyde, so therefore both give positive result with Tollens reagent. So only iodoform test can be used to distinguish between ethanal and propanal.
Question 38. Which pairs of compounds may be distinguished from each other by testing with alkaline aqueous iodine? Now, alkaline aqueous iodine gives positive result with these compounds. If it is an alcohol, there must be CH3 attached with the carbon atom having OH, and it shouldn't be tertiary alcohol. If it is aldehyde, then there must be CH3 directly attached with the carbonyl carbon. If it is a ketone, then there must be a CH3 group directly attached with carbonyl. Let's look into the options. In 1 we have ethane 1,2-diol. Let's draw. We have 2 carbon atoms as it is ethane. On first carbon and second carbon we have alcohol groups. Second is ethanol. As we can see that in ethane 1,2-diol, no CH3 is attached with OH carbon, so therefore this will not give positive result. In ethanol we can see that CH3 is present with carbon having OH, so this will give positive result. So we can distinguish both these by using alkaline aqueous iodine, so option 1 is correct. Option 2 we have propane 2-ol. In propane we have 3 carbon atoms and 2-ol means that OH is on second carbon. Second is methyl propane 2-ol. So again we have propane 2-ol and methyl group is also present on second carbon. As in propane 2-ol we have CH3 attached with the carbon atom having OH, so it will give positive result with alkaline aqueous iodine. Methyl propane 2-ol we can see that we have tertiary alcohol as this carbon is attached to 3 other carbon atoms, so therefore oxidation of tertiary alcohol does not take place. It won't give positive result with alkaline aqueous iodine, so we can differentiate these two based on this test. In 3 we have ethanol. Ethanol is having 2 carbon atoms and alcohol present. Butane 2-ol. In butane 2-ol we have 4 carbon atoms in the long chain and we have secondary alcohol group. As we can see that in ethanol CH3 is attached with the carbon atom having OH, so it will give positive result with alkaline aqueous iodine. Again in butane 2-ol we can see that CH3 is attached with the carbon atom having OH, so this will also give positive result with alkaline aqueous iodine. As both will give positive results, so therefore we cannot differentiate these two based on this test. As option 1 and 2 is correct, the answer is therefore B. Question 27. Which compound shows optical isomerism and gives a positive test with alkaline aqueous iodine? Optical isomerism is shown by those compounds that have chiral carbon. Chiral carbon is the one that is attached with 4 different elements or groups, and alkaline aqueous iodine gives positive result only with those compounds that have CH3 attached with OH carbon or CH3 attached with carbonyl carbon. Let's find out the chiral carbon. In A we have CH3, C double bond O, CH, OH, CH3. As we can see that this carbon is attached with one hydrogen atom, one OH, one CH3 and one this group. So this carbon is chiral. So it will give optical isomerism. We can also see that CH3 is attached with carbonyl carbon. So this will also give positive test with alkaline aqueous iodine. So A is the correct option. Now B is CH3, then carbonyl carbon. Then we have CH2, CH2 and OH. As we can see that there is no chiral carbon present because no carbon is making 4 single covalent bonds with different atoms or groups. So therefore B will not give optical isomerism and it is wrong. Then we can see that CH3 is present with carbonyl carbon, so it will give positive result with aqueous alkaline iodine. C is alcohol, we have CH2, OH, then CH with CH3 as substituent, and then we have aldehyde. Now we can see that this carbon is chiral carbon as it is attached with one hydrogen, one CH3, this group and this group, so it will give optical isomer. But we can see that there is no CH3 present with OH carbon or carbonyl carbon, so therefore it will not give positive test with alkaline aqueous iodine. Now with the last one we have two CH3 attached with carbon. Also OH is attached with this carbon, and we have aldehyde. As we can see that no carbon is attached with 4 different groups, so therefore we don't have optical isomerism. Also we can see that this is tertiary alcohol as OH is attached with this carbon which is directly attached to 3 carbon atoms. So tertiary alcohol does not give positive test with alkaline aqueous iodine. Correct answer is therefore A. Thanks for watching. If this was useful, please do like, subscribe and share.